of this session will be weird because the laptop right there. But here we go. Starting with 9. We're not going to do that. Number 6 is cotangent of x squared y squared equal to x squared plus y cubed plus 2x y squared. Can you guys all see this?
Yes.
Okay. So it's like what you guys have been doing with the chain rule, outside and inside. What's the derivative of cotangent?
Negative cosecant squared.
Negative cosecant squared. We rewrite what's inside, so x squared, y squared, and then what? The derivative of the inside, which is going to be what rule? Product rule. So we do x squared. The derivative of the y squared is what? 2y times y. That's because of the chain rule plus y squared times 2x. Not too bad. Equal to, what's the derivative of x squared? 2x. Plus what? Yep. Plus 2. And then the product rule again, which is going to be x times 2y y prime plus y squared times 1. Did you guys all get that far? Who wants to tell me the next step? Yeah. We have to get y squared on the outside. So they took a step, but let's all multiply. Negative y squared, or just y. Negative y prime times 2y times x squared times cosecant squared of x squared y squared plus y squared 2x times negative cosecant squared x squared y squared, and then that's equal to everything else on this side. 3y squared times y prime plus 2x plus 2 times the quantity of that entire derivative. You guys with me so far?
Yeah.
So the game-breaking plan here was multiplying the y prime up. Yeah.
The derivative would be 2x y squared. Did you not just leave 2 the x squared? Is that right, equal to a prime? No, very over. No, on the other side of it. Very, very,
Right.
yeah, very last.
This,
And you pull the 2 out. Is that
I didn't pull it out, I just kept these two together. It doesn't matter, you could have multiplied the two both parts. It's just, oh wait, at this point though, we would actually do something. Yeah. Because there is a y prime in there. I said, okay, so we have 4x y prime plus 2y squared, right? The main idea is to isolate the y primes away from everything else so we can combine them and put them on one side. Most people who lose points in this step because they try to do this in their head or they make mistakes like I made back then. Therefore, y prime is multiplied with negative y prime. 2yx squared cosecant squared times x squared y squared plus 4xy plus 3y squared. These are plus signs because I pulled out a negative. I pulled out a negative y prime from everything. So that's why they're plus inside the parentheses. And this whole thing is equal to 2xy squared cosecant squared x squared y squared plus 2y squared plus y. Therefore, we have our answer, which is negative 'y prime is equal to negative 2, and then have it times the quantity of xy squared cosecant squared x squared y squared plus y squared plus x all over. This side, everything has a y, so this is how it's a y. Y times the quantity of 2x squared cosecant squared x squared y squared plus 4x plus 3y. One thing to note is that you do need to take this 2 out and this y out. Okay? It simplifies it. So in the answer, they want to see that. Any questions? Are you guys good with this?
Yes.
People lose points just on the algebra mainly. So make sure you guys are careful. This is equal to sine of 2x plus 1 squared, and then that entire quantity to the 1/2 power. This way it's a bit easier to see the table, so then y prime is equal to, you bring the 1/2 down, we have the quantity of sine of 2x plus 1 squared. What power does that have now? Negative 1/2. What is the derivative of sine? Cosine of 2x plus 1 squared. What is the derivative of 2x plus 1 quantity squared? 2 times 2x plus 1 times 2. Now, something that people get confused on is that the square is on top of the 2x plus 1. It's not sine squared. Okay? If it was sine squared, we take the 2 down and then we write sine and then do cosine. Okay? It's the 2x plus 1 that's just being squared. And then this can just be simplified to 2 times 2x plus 1 cosine of 2x plus 1 quantity squared all over square root of sine of 2x plus 1 quantity squared. This 2 cancels out this one now. Are you guys all good with this? Yeah. And the last one. Cosine of secant of 3x squared plus 2 cubed. So what's the first thing that I write? What's the first thing?
Negative side of all that.
Negative sine of secant of 3x squared plus 2, that quantity cubed. What's the, okay, so we took the derivative of cosine. What's the derivative of secant? So we can write secant of 3x squared plus 2 quantity cubed, tangent of 3x squared plus 2 quantity cubed. So we did secant. What's the derivative of 3x squared plus 2 quantity cubed? Yeah, so 3 times the quantity of 3x squared plus 2, that quantity squared. What's the derivative of the inside? 6x. Again, the basic idea was y is equal to y is equal to. The basic idea is to not lose track of where you are in each step. Take the derivative of the outside and keep moving inside. And then you will need to simplify this. That's negative 18x times 3x squared plus 2 quantity squared. Secant of 3x squared plus 2 quantity cubed, tangent of 3x squared plus 2 quantity cubed. The entire thing multiplied by sine of secant of 3x squared plus 2 cubed. On. Sometimes they like for you guys to write in this order. We have something with a lower degree, something that's squared. It gets more confusing with trig, because those are cubed. And then the most confusing one at the end. It's just a way mathematicians write answers. That's not really necessary though. It is necessary to put negative 18 in. Okay. Are we good with this? Yeah.
Are they gonna worry about using parentheses from like CA and everything, or like, are we doing that?
You need to be clear that these are multiplied, okay? And this is multiplied with that.
They will not.
It won't take points away. Unless if there was a plus sign or something and you forgot parentheses, then it would like, if this was plus here and then these were multiplied, you would need the outside parentheses to represent each individual quantity. You guys understand what I meant by that? Like, since these are all multiplied, you don't need to worry about parentheses, but you do need to make sure when you need them. Any other questions? No? On to linearization. So, first of all, what is the formula for linearization? Who knows this? Let's write that. F of A plus F prime of A times X minus minus A. Do you need that memorized? So the function they give us is square root of 7x plus 1 at x equals 5. So to get f of 5, that's pretty simple. I just plug in 5 for x. That's the square root of 36, which is just 6. Okay? At prime of x. That means we need to take the derivative. This can be rewritten as 7x plus 1 to the 1/2, which makes the derivative 1/2 times 7x plus 1 to the negative 1/2 times 7, which can be rewritten as 7 over 2 times 7x plus 1 to 1/2. Yeah. Right? You guys should know that by now. F prime of 5 is just plugging in 5. So 7 over 2 times 36 to the 1/2. That's 7 over 12. Those should be like easy points on the exam. Make sure you guys don't mess up on this algebra. So, what would the L of x be? Once we've found all of these, it's just plugging in for each place. So if we want L of x at x equals 5, we need f of 5 plus f prime of 5 times x minus 5. We already found f of 5 and f prime of 5. They will ask you those, so you sort of know what to plug in. Like they'll ask you each of those. Yeah.
Where are you placing the negative 5? You said it's showing accent.
The linearization gives us a formula, which is a linear equation. So, x in a linear equation, we have mx as the slope. So, this is approximately 6 plus 7 over 12 times x minus 5. Or is there 1 over 12 times 7x plus 37. If you want to really simplify it, but you don't need to. Are you guys all good with that? It's pretty straightforward if you remember the formula. So for part B, it says use A to approximate square root of 35.3. In reality, taking the square root of 35.3 is really hard. But since we found an equation that relates to this, we can just use the linear equation. The square root of 35.3 is the same thing as the square root of 7 times 4.9 plus 1. This is not given, okay? You guys will need to figure that out.
No, no.
Did he give you guys one?
There's no way. Would you give it?
Okay.
Are you sure?
It's hard to tell whether they give it to you or not from the practice exams. I would say you guys need to figure that out. They might give it to you, but just to be safe, it's not hard to figure that out, okay? You look at this is the square root of 7x plus 1, okay? This has to directly follow what that looks like. It's the square root of 7 times some value plus 1, okay? So you just have to find what x is. So 35.3 minus 1 is 34.3. Okay? Divide by 7, we get 4, 28, 8. Did I do that right? 63. 16. You guys see how I got 4.9 from that? It's sort of doing it backwards. So, if that was 6x plus 2, right? Of course, that equation would be different, but we do 35.3 minus 2, that's 33.3. Divide that by 6, and then you have your x values. Okay? I'll leave that there. So then, that's equal to the actual function at 4.9, which is approximately equal to the linearization at 4.9. And then we have that equation, that's equal to 6 plus 7 over 12 times 4.9, and then we have minus 5, minus 5, that's equal to 6, this is equal to 0.1, so 6 minus 7 over 120, that's 713 over 120. Yeah.
On the test, we take that linearization as 6 plus 7 or 12 or
Yeah.
we do that again. But I mean, like we do that on the test, we can distribute the 7.
No, this is,
Sorry.
if you wanted to, you could do it. You don't need to. So the reason we do linearization is to solve tough square root problems like 35.3, because if we have an equation that's similar to how it should be, we can just plug in an x value. Any questions on that? Are you guys all good at finding the x value? So if you are we good with this? And then sorry for the people watching, it's not really clear that I'm writing on this side. It should have come. There's some people who can't, so.
Do you know how many views you get?
Some of them are like 40. All right, number 8. So this is the very last column. I'm thinking under the OneNote, but Jordan, exam, we forgot to put it on there. Okay. This is the one Use differential to approximate how accurately accurately in percent. You should measure the radius of a circle. To have an area within plus or minus 6. Of true value. Okay? So this is about accuracy. That's a key word in the problem. It's not exactly like related rates. Okay? So first thing you need to look for is what formula to use. You can tell that because they'll give you a certain shape. In this one, they tell us a circle. So what's the formula for the area of a circle? What's the derivative of this? Is equals to dr. Okay? They tell us that we want the area to be accurate within plus or minus 6%. This is just something that you need to know from the video. Since we want the area within plus or minus 6% accuracy, dA over A has to be equal to plus or minus 0.6. 0.06. This is something that they showed with the graph about error and stuff. Okay? So whenever you have something with accuracy with plus or minus something, you need to know that variable, derivative of it, over the actual variable. So we know what dA over A is. And we have dA. What do we do here? Divide by the original function so that we have dA over A. So we divide that by pi r squared. That's equal to, so the pi's cancel out, one of the r's cancel out, you have 2 times dr over r. Okay? What were they asking for? We have to measure the radius of the circle. We have to find the accuracy, but we have to measure the radius with, right? Accuracy, again, would be dr over r for the radius. Once we simplify the formula, that's exactly what we got. So on your problem, if you have simplified it right, you'll get variables with the derivative over that. Okay? So it will work out. So if it doesn't, that means you probably messed up in this step here. So we know what dA is. Plus or minus 0.06 is equal to 2 dr over r. Therefore, dr over r is equal to plus or minus 0.03, which is within 3%. I think you should probably just put like accuracy 3% or something like that. Or show that you multiply this by 100 equal to 3%. Any questions on this? Yeah, you need to present. Oh, plus or minus, yeah. You do need a plus or minus. So, let me see if I can think of So if I had the formula of let's do a rectangle, area times base times height, okay? dA of this is equal to dB times h plus h, sorry, yeah, b times dh, okay? Divided by a, divided by base times height, dA over a is equal to dB over b times, so if you were to separate this, the h's would cancel out, so it'd just be that, plus dH over h. Okay? If you had this, they would tell you two of these. So they might give you the area accuracy and the base accuracy. You need to find the height accuracy. Okay? So the important part was this step, and then simplifying it to get that. Yeah.
So is accuracy like error?
Yeah. But you need to remember it's the change over the. Yeah.
You said they were two of those in the front of the last one, right? They use subtract the problems.
Yeah.
Okay.
So for this, it came into, we only had one variable there. Yeah.
Are they gonna give us the formula stuff you need, or we know I need to serve volume minus meter?
So for area of a circle, they won't give you that.
Yeah.
For like volume of a sphere, they'll probably give you that, but that's for pi r cubed. No, it's 4 cubed or 4? 4/3. Yeah. Pi r cubed. The surface of a sphere is 4 pi r squared.
No.
But I do believe they'll give this. Just in case though, so what's the surface area of a sphere? What's the formula for that? I just said 4 pi r squared. Area, volume of a sphere. 4/3 pi r cubed. Are you guys good with this? Oh. Right. Alrighty, on to max and min stuff. So you're given y is equal to the function of x, which is 3x 2/3 minus x squared, negative, and the domain is negative x less than x, less than or equal to between negative 8 and 8. Okay? So for a, they ask you to find the prime of x. So what did you guys find for x prime? Place 2x. What's the first step? So it means 3 times what? 2/3 times x to the what? Negative 1/3 plus quantity minus 2x. That's equal to 2 over x to the 1/3 minus 2x. That's 2 times 1 minus x to the 4/3 all over x to the 1/3. It shouldn't, if you guys know that. Are we good with that? I'm not sure if they want you to simplify all the way to that point.
Let's say, what does it say? 1 minus x.
Yeah, 1 minus x over x. But you guys should try to simplify it as far as you can. Then they ask, find all the candidates for max and min. So what is step 1?
0.
Where the derivative is 0. F prime of x equals to 0. So we make that 0. So, okay. The reason they wanted you guys to get to this form is because now you have a denominator over everything. Okay? That makes it easier to see what words undefined, defined, and stuff. Yeah. There we go. So we set that equal to 0. What values do we get? First off, we have x plus 4/3 has to equal 1. Therefore, minus 1. X would equal to plus or minus 1. And so then because those points, should we find all the candidates? You have to do it step by step. So just right now we're looking at where the derivative equals to 0. Okay.
Could you highlight candidates first and then test all functions? That's how we did it during the still file candidates.
Okay.
First we do it all.
The way that test is organized, well, I would say do it right there, because part B is to find all of them, right? So you write 1, and you do this, 2, you do words undefined, 3 the endpoints. It's easier to just test them right there, so you are organized that way. And this way they can see directly that you found the live outcome. So I would do it this way. So when x is equal to 1, y is equal to 2. When x is equal to negative 1, y is equal to 2 again. So we have the 2 coordinates, 1, 2, negative 1, 2. Any questions on that? This is a really huge topic that you guys should understand. And then you get into actual things with like boxes, finding the max values of base and stuff. So what's the second step? Where is it undefined? 0. When x is equal to 0. And that's when y is equal to 0. Therefore, we have a coordinate of 0, 0. What's the third step? Good. So we test the left endpoint first, which is x is equal to negative 8. Y is equal to 3 times negative 8. to the 2/3 minus a negative 8 squared. That's 12 minus 64, negative 52. Therefore, that coordinate is negative 8 comma negative 52. The right, x is equal to positive 8. So you plug that in, y is equal to 3 times 8 times 2/3 minus 8 squared. That's 12 minus 64 again, which is negative 52. So we have coordinate of 8 comma negative 52. Any questions with that? Then they ask you to make a sine chart and to clearly justify them. So we have 8 and negative 8 on the end. In this, we basically mark all the points that we got, all the x values. We have negative 1, 0, and a positive 1. You guys should all be familiar with the sine chart. Yeah. So we have this test at each place. It's basically just taking random values from the left between negative 8 and negative 1. We have a negative over negative, which is a positive. Between negative 1 and 0, we have a positive over a minus, which is a negative. 0 and 1, positive over a minus, negative. And between 1 and 8, negative over a positive, which is minus. Is this right?
Second positive. Or like the very last one, should it be positive or positive?
Oh, this one did it. There's one more mistake here.
Here's the little arrow.
Oh, yeah.
I'm missing the arrows. It's 0 at negative 1 and 1, and undefined at 0. Okay?
Right there.
Yeah, like 8 and
So all of that has to be linked.
yeah.
Can we write the sign over like one time or just have to be written multiple times?
This?
Yeah.
It doesn't have to be written multiple times.
I didn't think so.
But that's the way, they've always done it. You just need to be careful of clear. Are you guys good with this? Make sure you guys have everything included. And I'll erase all of this. Are you guys good with this? Yeah. So the next part is finding whether they're actually massive or minutes. And you do have to justify that, but that's just the process. So in step 1, we found negative 1 and 1, okay? The great thing about a derivative is that it tells you the slope. So we can just look at the slopes. If the slope is rising and then falling, we know that's an x. If it's negative and then a positive, we know that's a min. Okay? And then they did that base thing with the second derivative. So at the time of negative 1, when we approach it from the negative side, is it positive or negative? Positive. At the time of negative 1, as you approach it from the positive side, is it positive or negative? Therefore, what do we have? Local max at -1, because the slope rises and then it falls. And we know it's 0 at that point.
We draw like the whole, like, view, they wouldn't like have it wrong or something, just like, travel, even though
Do you have it?
I don't think, this is not necessary.
You don't have to go. Okay.
I'm pretty sure it's not necessary. This is the justification and your work. This is, to help you guys visualize. They drew it on here, the solutions. So if you guys do want to draw it, you can draw it, but they shouldn't take points off of this. And the second point that we found with step 1 is a +1. So from the negative side, what is it? Greater than 0. And from the right side, it is what?
less than 0.
Less than 0. Therefore, local max at 1, 2. Is it 1, 2? Are you guys good with that? Second step, we found where it was undefined. That was at 0. At time of 0 from the negative side is what? Less than 0. And at the time, the 0 from the positive side is what? Therefore, what? Local min. At 0 from 0. That's because the slope is going down and going up. Are you guys good with that? 3 is testing the endpoints. If we approach -1 from the left side, can we approach it from the left side? No. We can only approach it from the right side. Is it greater or less than 0? So is it a max or min? It's a min. Make sure you guys understand why it's a min. Because if I have -8 and the slope is greater than 0, that means the curve is going up. That is a min. It's lower than the next point. Let's do S prime at 8. You can only approach it from the left side. Is that greater than or less than 0? Less than 0. Therefore, what is it? Local min. So the idea changes from the other side. So that's 8 -2. Because if you were to look at that, the slope is less than 0, so it's coming down. The next point is higher than it, so it's a min.
I can draw the little pictures.
I normally always draw these two. Just because in my mind I want to see that. But those should not be necessary. They have them on here, so if you do want to draw them, draw them. Just to make sure that you're doing it right, you can draw them. But I highly doubt it that they would count that for points. So then, we do have to state what is the overall max and min. So the max is where? When y equals what?
2
2. At what point?
plus or minus 1.
Comma 2.
Plus or minus 1.
You need to write plus or minus 1 because it was at 2 points. Okay?
If we wrote it as 2 points.
That would be fine. You could even have had points like 2, comma 2. So you would have needed to state all 3 of them. Okay? If some point repeats 3 times and it's an max or min, you need to state all the points that it occurs at. So the min is -52, and that occurs at plus or minus 8.
We know that the minus 8, but the other 8 is
They're both -52 at plus or minus 8 if you plug that in. -52 is the lowest y value. That's why it's the absolute min. Any questions on this?
Yeah, so endpoints can be absolute max.
Yeah. So, yeah.
Daniel, I think that's like another question on the homework, like, where you're supposed to know if there is, if the function isn't went on forever, that there is technically no absolute maximum kind of thing. Like, if it's not supposed to happen.
If you found that the slope, like if you have something like this,
Yeah, you see, in the domain is forever.
yeah. Since it's getting smaller and smaller, you'll have local mins and local maxes, but you'll never have absolute. Okay? Now, if a function, say, is that, like negative x squared, okay? This is a local, what? Max? Does this have a local min or an absolute min? Because it goes on forever. So this only has a local max.
absolute.
Sorry, absolute.
Yes.
Yeah. This is that's absolute.
Right.
Yeah. Or it's local max as well, but since it's only one, it's the absolute. Are you guys good with this? It's very important that you understand this, because you get crazy with this stuff. So I'm going to erase this. And then we'll do a related problem. And then I'll do a problem with one of the homework problems that you guys did in class with an angle, like d theta or dt, something like that. Because that could be on your exam. It's probably will. Any questions? Okay. So this one, water is leaking from a circular cone, and they give you the formula of it. Pi r squared minus h all over 3. That's the formula of a circular cone, and it's leaking at a rate of 2 centimeters cubed per second. Find the rate at which the level is changing. When the water level is 6 centimeters above the water. Okay? First things first, they gave you a formula, so you guys should be thankful. Yep. Second thing, you can write the formula again, and you find dV. dV dt. But for this problem, actually, we have two variables, r and h. Okay? So the first thing we actually need to do with this problem is relate r and h. So if we were to draw out the actual cone, its height is 10 centimeters, and its diameter is 6 centimeters. Okay? We need to relate radius and height. So we can actually make a triangle. The radius will be at 3, height is at 10. Using similar triangles, the smaller radius we can call r, and this new height h. Okay? R over h is equal to 3 over 10. R is equal to 3/10 h. They should have done a problem like this in class, right?
Is that 6 meters or 6 centimeters?
That's 6 centimeters. Sorry.
They don't just gonna try and grow like an change.
It's usually consistent, they don't try to mess with that. But if it does happen, make sure you guys. So we can just sub it in, we get 1/3 5 times 3 over 10 h squared times 8. That's equal to 3 pi h cubed over 800. We were able to get that knowing that we needed h as a variable in here, but it told us that the level was changing at this rate. Okay? That's it. That's essentially dh over dt. Okay? So now we need to take the derivative of this with respect to time. So the related rate is with respect to time. So dv over dt is equal to, you guys want to say?
9 pi.
Oh, right now we can write 3 pi over 100
Times 3h squared.
3x squared times dh dt. That can be equal to 9 pi h squared over 100 dh. We have dh dt because that's the chain rule. We're not taking the derivative with respect to volume. It's with respect to time. Yeah.
So we found that R equals 3/10 h. Is still the same formula, right?
Yeah.
Okay.
Using similar triangles, we use this relationship. It's going to hold for the entire concept. So R will always be equal to 3/10 h. So this is very important because now we can relate the change in the volume of the water with the change in height. So it's asking us find when the water level is 6 centimeters above the ground. Find the rate, okay? So we need to find dH over dt at h is equal to 6 centimeters. Okay? So just solving for dH dt, we have 100 over 9 pi. They told us the volume was changing at a 2 centimeters cubed per second. we need to recognize that it is a negative because the volume is decreasing. So that at 8 equals 6. -2 centimeters per second. All over. We divide by 3 squared, so we need to multiply that. 3. Sorry. We divide by h squared. So that's 6 squared centimeters. Okay? Yeah.
Why do we divide by 6? Where are we going?
I just, you solve for dHdt. So you multiply d over dt by the reverse of it. So 100 over 9 pi, h squared at the bottom. This turns out to be, you guys do it?
-1 centimeters over 875 seconds.
What did you say?
-1 centimeters over 875 seconds. That'd be my math wrong.
Yeah. -50 over 81 pi. So that's centimeters per second. Let's see. There's 2.
The 36.
This is a 36. That turned out to be 18. Right? This 18 divided by 2 is a 9. You get a 50 on the top. 9 times 9 is 18. This tells us what?
The height is decreasing by that much.
Yep. 2 things to know. We know that the height has to be decreasing. So, if we were right, we got a negative answer. Okay? The height is a centimeter value, so its units should be centimeters over a second. Okay? When we look at the units on this, we have seconds in the denominator, and we should have centimeters on the top.
It makes sense.
This is centimeters too. There we go. So the units work out as well. Yeah.
Like, you wrote the line with the H equals 6.
Yeah.
Don't do that.
They won't. That's not necessary.
They take it off of the fire test.
They what?
They take it off of the fire test.
Yeah.
All of your records.
So they took points out for not showing that. If you don't show that h is equal to 6, but you plugged in 6 here, you should ask for points back. And if they're nice enough, they might.
They will.
Did you ask that?
That's really nice. Yeah.
You did ask them. Yeah, you should ask them.
I asked them all, it's like, why? I was like, well, I got almost taken off already.
Yeah, you should write.
I didn't have my pencil.
You asked for a pencil, right?
I cannot ask them my pencil.
Okay, are you guys good with that? So one of the main ideas that we use in this was to get it in terms of just h, to get dh over dt. Right? And then if you guys want to stay, I'll go over a problem with data and d data, but that could very well be on the test. And I'll just do a homework problem that they did in class and explain that. Can I erase this? Also, we can do a problem like this, go over the Newtonian method. Remember that the Newtonian method was Xn equal to XO plus X over F sine, something like that. That may very well be on the exam. Yes, it'll be simple numbers, so you can do it quickly there.
Because they made us do decimals. You can't do that, it's not.
It probably won't be decimals, but if it is decimals, convert them to fractions, it's like over 10 over 100. Yeah, they'll probably use it. Just remember how to do it as well. Okay. So this is the problem in class. Do you guys want me to do the moving car one, while videotaping it, or the airplane one? The airplane one? Wait, who thinks the car is harder?
I didn't do the car. Oh, geez, let's do that one.
Who thinks the airplane is harder?
Which airplane? I like the world. Which one is it?
The airplane going one way, the car up there is going one way.
That's how it's.
Okay, yeah, let's do the normal one.
The plane one doesn't have a.
So, you have a moving car, and they give you a little diagram. And you have theta. So the car is moving at 264 feet per second. And you have to find how fast the camera moves at when the car is at this point and when it's half a second at point 2. So they give you that formula, which is really nice. I'm sorry, the diagram. Otherwise, first things first, they tell us that it's moving at 264 feet per second, right?
Right.
That's equal to, if we mark this as x, the change in x, okay? That's equal to dx over dt. Now, since we are approaching, the x is getting closer. This is negative, okay? You just have to interpret that. We have to find d theta over dt, and theta is equal to 0. Okay? So the change in theta. Just by looking at this, we have two things, 132 and x. Okay? You can find the hypotenuse, and you'll have a variable in it, but that'd be stupid to do, because then the problem will be confusing. We already know tangent of theta relates those two quantities as x over 132. Okay? So you could have done sine of theta using the hypotenuse, but that would just be way more work. Okay? And my phone froze. So what would the derivative of that be?
Secant squared.
Again, d theta dt is needed because we're taking the derivative with respect to time. One second. Yeah. 1 over 32. 132 times dx over dt. Are you guys all good with that? Luckily, we know dx dt. This is what we are looking for, and we know what theta is. So we only have one variable. d theta over dt is equal to 1 over 132 dxdt, we already know, is negative 264 feet per second, so I don't want to rewrite that. Feet per second. Divided by 1 over c squared. You could do that, but you can just leave it at 0.
Yeah.
Okay. This is just 1, you know that? You get a 2 on top, negative 2. This was feet. So the feet cross out. We're left with negative 2 radians per second. It's lower seconds, but radians is normally associated with it. Okay? And you guys do need to write out always the units if they're given. They'll take the point off the top if you don't. So with related rates, like centimeters per second, you do need to write it out as centimeters per second. Yeah.
We missed something this week.
1 versus 1. Yeah.
Each.
Yeah. All right. So that's part A. The main idea was finding out a formula that we can work with. Okay? Tangent of theta x over 132. For part B, we can draw another diagram. Theta x 132. Okay? This time, x is growing bigger. Okay? So it's 264 feet per second. And we want to know at 1.5 seconds, right?
Right.
If we know that it's 264 per second, right? X is easy to find. That's just looking at the units that we want. 264 feet per second. We can just multiply that by 1.5 seconds. We get 132 feet. Okay? So that's something that you just needed to know with rates, rate over time. So, like, distance is equal to rate over time times time. Is that right? Or whatever it should be.
Looks good.
Yeah. We can look at the same formula again. Tangent of theta is equal to x over 132, which we found out is 132, so that's just equal to 1. Theta is equal to pi over 4. Even if you didn't realize this is a 45-45 triangle, what is tangent of theta 1? Pi over 4. Okay? So even if you don't recognize that's 45-45, you can always do the inverse tan. And they still want d theta over dt when at 1.5 seconds, right? So d theta over dt at theta equal to pi over 4. We can again use the original equation that we found for d theta over dt. 1 over 132. Put that feet there. This time the rate is not negative, it's 264 feet per second over secant squared of now pi over 4. Okay? That's 2. So we have 2 over 2 divided by square root of 2. If you just square root of 2, square So don't get confused at a secant squared at the bottom. That's equal to cosine squared of pi over 4 on top. That's 1 over square root of 2 quantity squared. That's 1/2. So 2 divided by 2 equals 1. If you need to write all that out, do it, but don't make a mistake. Yes.
That is not the main problem. It's probably-
It depends. You have to know how to interpret it. Like this time, they gave you that diagram with the car moving like that, right? I had last year some weird thing where it was 2 shores and a boat was going this way. There was a lamp or something watching it.
The lamp is watching it.
And then find out the rate at which this was moving, something like that. And I wasn't able to interpret it correctly, so I didn't get full points, but I knew what was going on, sort of. So I wrote out the formula for the Pythagorean theorem, with the derivative of that, did some math. So I didn't get full points, but since I wrote out the formula with the derivative, I got some points. So if you can't solve it all the way, make sure you do it at least last time. Are you guys good? Yeah. That was sort of with the GA or A. Make sure you guys go into that review that I put up. That's very important. Okay? There's absolute change, there's related change, and all the formulas are there. Also remember, they could still have a proof of like summation, the product rule, or the quotient rule on this exam. They might even do the power rule this time.
What about the chain rule?
Yeah. Also driving identities, that sort of thing, that's still part of this test. So, nothing is ever forgotten.
They want to weed this out.
Yeah.
They want to- What do you say?